Thanks.
Yes, me too.
Okay. So I keep trying to find her stuff, her examples for our the project that we're doing.
Yeah.
And I can't find them. I thought she said something about the resources folder. I went to the resources folder and I didn't see any kind of samples.
I can't find them either.
I'll just email her then. Figure that. I'll ask her.
Let me check one thing real fast. Yeah, I don't know.
Sorry.
Yeah, because that's due this week, right? The first part is.
You know, I think so. I know that there's a section that says something about it, but I don't know if it's the actual first part of it's due or if it's due next week.
Oh yeah, it might be due next week. It says it starts today, so you could. There's a design the study self-report quiz, and it starts today, so it opens today and it ends on November 18th. So.
Yeah.
Yeah.
I even opened up the design study instructions, and there's nothing in there.
Yeah, there's nothing in there either. I haven't checked the conversations discussion board. I wonder if there's anything on there. I should ask.
Oh, yeah. Oh, yeah, we can look there.
Awesome. Do you have the quiz pulled up?
I do. I've been working on it. Yeah.
Okay. Do you want to start, Carrie?
Yeah, I will. Okay. 3. In a pie chart, why are the slices or sectors different sizes? Do you want me to read the answers or?
I think it's C.
Yeah, I think it's C as well.
Me too.
How are bar charts and Pareto charts related?
It's C.
It's C again.
Yes. We conclude that p hat is normally distributed if NP is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. If is p the true proportion or sample proportion?
True.
True proportion.
All right, you got number 6.
Okay, what is n?
The sample size?
Yeah, that's what I put.
Yeah. Sure, it's not the number of candidates in the election. Tomorrow's voting day, you know.
P equals 1 out of 4. What is the smallest n that satisfies the requirement?
Yeah, this one I don't understand.
I think you just plug it in, so it'd be n times 1/4. And it has to be greater than or equal to 10.
So n times 0.25?
We have to do it for both. So the first one is 40. The second requirement is.
Okay, wait, where are you at? What do you?
A little bit. Yeah, so I did it on this piece of paper. So n is greater than or equal to 40, and then this other one, which I did.
How do you know that n equals 40 then?
Because 10 divided by 0.25.
Oh.
And then on the other side, it would be
13 1/3.
40 times.
So 40 times.
No, we don't put in 40 for that one.
Well, I'm just saying, if this one was greater than or equal to 40, then we put 40 in.
So would it just be 10 divided by 40?
Okay.
So that's 30, so 40 doesn't work. We have to figure out this one.
Oh, I got 13 1/3.
But yeah, it's 30.
Which is bigger than 10. Yeah.
What did you guys do?
Wait, you're saying you got 13 1/3 for what n should equal to be greater than or equal to 10?
So we want the greatest one, which is 40.
Yeah.
Okay, it's 40, Carrie.
The answer is 40.
Yeah, so you know how there's the two requirements? There's NP is greater than 10 and N times 1 minus P is greater than 10.
Mhm.
If you solve both of them for N, you want the biggest number because they both have to be met. And so the first one is 40, and that's the biggest one.
Yeah, because then the N times 1 minus P would be like 39, wouldn't it?
I got 13.333 if you do the whole thing.
Okay, I guess that's confusing me and I'm not getting it. I'm sorry.
So instead of we're on the second one, we're looking for N again. So I did 1 minus P, which is 3/4 or 0.75. So then I did 10 divided by 0.75.
Well, I just don't get how you're getting the 0.75s and things like that, I guess.
Oh, we're focusing on just the N times 1 minus P is greater than or equal to 10. So we plug in the 1/4 for P, or you can plug in 0.25 for P because it's equal.
Okay.
So then you do as much math on the left side as you can. So you do 1 minus 0.25, which comes out to 0.75. So now your equation looks like N times 0.75 is greater than or equal to 10. Algebra, we divide 0.75 on both sides. So then it's N is greater than or equal to 10 divided by 0.75, which is 13.3.
Okay.
Does that part make sense?
Okay, I'm trying to get this. I'm sorry. Okay,
Okay,
so
you're good.
Chalkboard, you know.
I know.
I know. Okay, can you go slow and explain it to me again?
Yeah.
So N. Okay, let's concentrate on the NP side. Okay, that is greater than 10. Okay, so what you got there is you got to stand for what number?
So you doing NP is greater than 10?
Yes.
So did you plug in the 1/4 for the P?
No. So
you have to
P is
put
equal to
Yeah, so it would be N times 1/4.
okay. So N times 0.25. So, but what's N?
N is the sample size. So
That's what we're trying to find.
Oh. Okay. So then 1 minus, so N times 1 minus 0.25, right?
yeah, for the other side.
So let's do this. That's 0.75, right?
Mm-hmm.
So then it's N times 0.75, correct?
Yeah.
Yep.
Yeah, so then you'd have to divide 0.75 to get N by itself.
So then it would be, oh my gosh.
What questions do you have, Carrie?
keep forgetting. Yeah, let me go on here. Let me see what you did, if you don't mind.
Yeah. Okay. So it is greater than or equal to 10, right?
Mm-hmm.
And then the other one is n times 1 minus p is greater than or equal to 10, right?
Mm-hmm.
Okay. So, and we know it tells us in the problem, it tells us what p is. What's p?
P is 1/4, so it's 0.25, right?
Okay. Yep. So n times 0.25 is greater than 10. Okay, greater than or equal to 10. So what do we have to do to get n by itself?
The part where we divide, right?
Yep. So we do 10 divided by 0.25, right?
Oh, yes, because then that crosses out. Okay, so this is your basic algebra thing. Okay.
So what do you get?
It's 40. Okay, so
40.
n
Okay,
equals,
perfect.
or n times 40. Is that what it's going to be now, is n times 40?
Nope, it's because we multiplied, or I guess, oh, sorry, we divided, we divided this by 0.25, so that isolated n by itself.
Yes.
So then we just have to divide 10 by 0.25. So now we have n by itself has to be greater than or equal to 40. Does that make sense?
Yeah, so let me see your screen. I'll stop talking so I can see it. Talk to me because it won't flash unless you're talking.
Oh, sorry. Can you see it yet?
There we go. Okay, so that's what I have written there. Okay, so then.
Okay. So both requirements, this one and this one, both have to be met. So now let's do the other one.
Okay.
We have n times 1 minus p is greater than or equal to 10, and p is 0.25, right?
Yes.
Of n times 1 minus 0.25 is greater than or equal to 10. So 1 minus 0.25, that's 0.75, right?
Correct.
Okay, so n times 0.75 is greater than or equal to 10. And then we do the same thing. To get n by itself, we have to divide both sides by 0.75.
Okay, so the one side is 40, the other side is 13.3333, whatever.
Yep. And we need them both to be satisfied. So we want to take the bigger number, because if n was 14, then this requirement would not be met, right?
Well,
does that make sense?
It's greater than 10 though. 13 would be, isn't it? Whatever.
It is greater than 10, but if we put it in the full equation, because it's not just n has to be bigger than 10, np has to be bigger than 10.
Oh, okay.
Yeah. So the answer is n is the lowest number n could be is 40 is the answer.
Okay. So this is going to help with the last two problems. Okay.
Awesome.
All right, so we're on question 8. Is it my turn?
Yep, your turn.
Okay, so what is the mean of P? Round to the 10th place.
I think it would just be 0.4. I think the mean is the same.
I do too.
Well, it's p hat, isn't it? Is it the same as p?
It's
Yeah, so
the same mean.
Yeah, the mean is going to be the same. It's kind of like mu.
Yeah.
Okay. I thought I had all this and I just don't have it.
What is the standard deviation of p hat?
Or do you have the equation for that, Carrie?
I do, but I totally, because like my answer for the one before it was 0.01, which was obviously wrong, and so then this one I put is 0.1.
Let me see what I get.
This is p hat is the root p. P parentheses 1 minus p.
P times 1 minus P divided by N.
Like that, right?
Yeah. Did you do this one then, Carrie?
Say that again.
Did you do this one yet?
Sorry.
Did you finish it yet?
Are you there?
Oh yeah, can you hear me?
I can now, yeah. Sorry, you were
Okay.
breaking up. I don't know why.
Oh, sorry.
The internet's been weird.
Yeah, it's been weird. Did you do that problem yet?
Like I said, I had done it earlier, but I obviously did it wrong. So now I have to figure out where I went wrong in order for me to.
What did you get when you did it before?
Well, for question 8, when I had done it before, I got 0.01, which was wrong anyway because it said round to the 10th place. So that should have been a hint to me. So then what I got for question 9 was 0.1.
I got.
And I don't remember how I did them. Oh, you know what? I think they're on this paper.
I got 0.1 for number 9.
You got 0.1?
Uh-huh.
Oh, so then maybe I wasn't wrong.
Let's see what Caleb gets.
I forget every time.
Hold on. So it's P times 1 minus P, right?
Oh, it's 0.4. I'm putting 0.04.
Oh, that would do it.
You know what? I
think it's 0.1.
I just worked mine in the calculator. That's why I'm not seeing the work for it.
Yeah, I got
I just did it in the calculator.
Yeah, you got it right. It's 0.1.
Awesome.
Okay.
Cool beans, cool beans.
Brittany's batting average is 0.3. We want to determine if the probability she will get more than 35 hits in her next 100 at-bats. N equals 100, P equals 0.3. What is P hat?
Okay, so what I understood was you would take, what I did was I took that 35 and divided it by 100 and got 0.35.
I think that's right. 0.35. Want to read 11?
Yeah, I'll read 11. Okay. What is the standard deviation of P hat?
Okay.
So I figured that out.
I'm gonna make sure we-
What did you get, Carrie?
0.046.
Yep, that's what we got. Perfect.
Awesome. Okay, maybe I did get just that one I didn't get. Okay, is it my turn?
Yeah.
What is the z-score?
Okay, so the z-score.
P score is a value minus mean, right?
Yeah.
So I did 0.35 minus 0.3 divided by the square root of 0.3 times 1 minus 0.3 divided by 100.
What'd you get?
1.091.
The z-score?
Yeah, for the z-score,
I
I
just
got
went
1.091.
Well, I got 1.0369.
Oh, you know what? Maybe I put the thing in the calculator. Let me try this really quick, if you guys don't mind. See, that was wrong. So I had separated, I did 0.35 minus 0.3 and I got 0.05.
Yeah, that's
And
right.
then I went and did the square root 0.3 times 1 minus 0.3 in the parentheses divided by 100.
Okay, that's right.
So then I did 0.5. Well, so maybe I did this. Let's see.
No, you did,
You did
it
it
right.
right. 1.091, right?
Correct. Yes.
Okay.
Yeah.
Yeah, you're that's right.
We got something different the first time because we used our rounded standard deviation from question 11 instead of keeping the unrounded standard deviation.
Ew.
Yeah, so you did it right.
That makes you feel good.
Yeah, good
Just
job.
kidding.
No, you should feel good. That's awesome.
I
What
get so
is the
tired of feeling dumb.
probability that Brittany gets at least 35 hits in her next 100 at bats? So we just put that z-score in the normal probability applet, right? And shade the right.
Correct.
I got 0.13138.
Correct. That's what I got.
Okay.
So it's 13%. Yeah. 1.138.
Right, we're in the next one. It loads.
Okay. Use the following information for the next 3 questions. If the true proportion of people who support a political candidate is P.52 and 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation for P-hat?
So I did. So I did the square root of 0.52 times 1 minus 0.52 divided by 2,000. Was that the right thing to do?
Yeah.
I got 0.011.
That's what I got.
Awesome.
Awesome.
So,
You want to read the next one, Carrie?
yeah, so these are the last two are the ones that I haven't done yet because I got confused. So it says, what is the z-score would use? So I was trying to figure out z-score, but I don't know how to figure it out with just those 2 numbers.
Oh, so at the bottom, it says, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. So we can use the 50%, the 0.5 as our P or whatever, P-hat, or whatever.
I have a question.
Oh, okay. So then I am going to get a negative number because I thought I was doing it wrong. I was getting a negative 46 point something because I stopped because I thought I was so wrong. Is that right? Okay, let's try.
So 0.
Because then you do point.
Because you have to find the difference if this is the true mean or the true whatever. It's you have to do 0.5 minus 0.52 divided by the standard deviation.
Oh, I see.
You know what I
Oh,
mean?
because this is the probability of that.
Uh-huh.
Okay.
What'd you get for the z-score? Have you done it yet? Have you done it?
1.71.
Do you do the z-score yet, Carrie?
Not yet. Let me
I didn't use the rounded
finish.
standard deviation. I used the other one.
So, okay, so yeah, it's negative. Oh, this is so cool. I was doing it right and I stopped myself because I was so mad. Okay, so at least I think it's right. So it's negative 1.790.
Yep.
Yeah.
It's got more numbers, but okay, cool. So that's my z-score. So I'm going to put that in here.
What is the probability that the survey results will show the candidate is losing, even though the true p equals 0.52? We got to put that in the applet.
0.03.
Do we want to shade the right side still, or do we want to shade the left side?
The left side. And I got 0.037. Is that what you got?
I will if I would be smart and plug it in the correct way. 1.790. Yeah, 0.0367, right?
Yep.
Yeah.
And you just round it to
Wait, how many
0.037. Which one?
12.
1.91. What did I put for 12? Oh, 1.091.
I'm done with school.
No, totally. I can't wait for it to be over.
I
That's
know.
probably nothing for y'all because you're me. It's been crazy. Oh my gosh, I swear I'm going to pull my hair out.
I have to talk
Hey, did you
myself
guys
out.
submit?
I'm really good.
I submitted it and we got them all right.
Yeah, Janessa got them all right.
Caleb for.
Awesome.
Anyways.
You guys are
Awesome. Thanks, Carrie.
Thank you, darling. Have a good night.
You too. We'll see you on Thursday.